This is the beginning of chapter 2, which is about transformation. So section 2.1 is about congruent figures. So we want to remember what congruent means. So remember the symbol for congruency is this little symbol. And two shapes are congruent if they are the same shape. The same shape and the same size. So they have to have all their sides. This is the same. I'm messing these up. All their sides have to be the same. Corresponding sides have to be the same length. And then the angles, corresponding angles have to be the same length. And remember, the number of stripes you put indicates corresponding and congruent, or not necessarily corresponding, but indicates congruent sides or angles. So if they are the same shape but not the same size, they're similar, right? That's the symbol for similar. So congruent, same shape and same size, not to be confused with similar, which is the same shape but different size. So as we're talking about congruency and different things like that, we're going to be talking about corresponding. So corresponding, like I just said, it's the same, the side that is proportional to the other side. In this case, our this side length here corresponds with this side length here, and this side length here corresponds with this side length here. So corresponding is they match up and they're in the same spot, but the shape could be flipped. You could have a square like this and then a square drawn on its side, and so the corresponding sides could be here, or the angles could be here and here. So corresponding is key though. You have to match up corresponding parts of the shapes. Coordinate grid, because we're going to be using this. So we start with point 3, 4, and the point that is reflected is point 3, negative 4, and it's reflected over the x-axis, right? And so we want to be very conscious of which is our x-axis now, the horizontal x-axis, and which is the y-axis, so that when a problem says to reflect over one of those, we're reflecting over the right axis. So the reflected point is called the image. So that's key. That's the reflected point. Okay? So we're just, it's like a mirror. Your reflection is going to be the same distance as the actual, right? So 3, 4 is 1, 2, 3, 4. From the x-axis, so we're going to reflect it, we're going to go 1, 2, 3, 4 the opposite direction. Okay, and we're going to just keep going because this is just kind of an introduction to get you ready for class tomorrow. So a transformation, this is going to be out of 2.2, changes a figure into another figure. The new figure is called the image. Just kind of we talked about with the point being the image point. So a translation is a transformation in which a figure slides, but does not turn. Every point of the figure moves the same distance in the same direction. So this here would be a slide, right? This, it turns. It's this way, and now it's this way. So that is not a translation. Okay? This is a translation. This is not a translation.